notice specifically we're going to talk about graphing linear equations. Now what we're going to do is split this section over 2 days, okay, because there's a lot of information in this section. And so what we're going to do is take 2 days. Today we'll cover the first half. Tomorrow we'll cover the second half. And so first of all, we need to define actually what is a linear equation. And so there are some things here that a linear equation is not, and that's what we're going to go ahead and talk about. Okay? A linear equation has an x, y, or both an x and a y. Okay? Has an x, has a y, or both an x and a y. So you know that's what it's going to have. Okay? Second, you know that the variables all have powers of 1. So you can't have something that's squared. You can't have something that's cubed. So the variables all have to have a power of 1. Okay, next. No variables are in the denominator. Okay, so you can't have a fraction with a variable in the denominator. Now that's not saying you can't have a fraction. You could have like 1/4. But it's saying that a variable is not in the denominator. So, has an x, a y, or both an x and a y. All variables have powers of 1. And there are no variables in the denominator. And then we have one final thing. No variables are multiplied together. So that basically means you can't have x times y. Can't have that. All right, so now you need to know the standard form of the equation of a line. We're going to talk about different equations of lines. This is one you need to get down. So I'm going to let you write this down because this is really important. And then we're going to talk about what the standard form looks like, what are some characteristics, and then we'll continue. Now you will also hear this referred to as the general form of the equation of a line. This is something that you will actually see on the state assessment that you take when you're juniors. And so you need to remember ax plus by equals c. Now a is bigger than or equal to, greater than or equal to 0. So that basically means that a is positive. Okay, so what that a is greater than 0 is that means a is positive. Okay, yes, a can be 0, that just means it's not there. Okay, a and b cannot both be 0 though. So you have to have one or the other. So you either have to have x, y, or both x and y, and that's what we talked about. What is a linear equation? A, b, and c are integers. Remember integers. That is a positive or negative whole number. So that means no fractions for a standard form of the equation of a line, and they have to have a GCF of 1. Okay. Now we'll talk a little bit about what that all means, but I just wanted you to get that down. So real quick, let's review linear equation because that's going to be our question on our expression in the next slide. Has an x, y, or both an x and a y. All variables have powers of 1. There are no variables in the denominator, and no variables are multiplied together. So with those 4 things in mind, I want you to go ahead and tell me, is the following a linear equation, yes or no? Does that fit those 4 characteristics? Yes, good job. Okay, because let's go through. Is there an x, y, or both an x and a y? Yeah, okay. So the next one, do all the variables have powers of 1? Yep. Okay, are there any variables in the denominator? Nope. And then finally, are any variables multiplied together? Nope. So this is a linear equation. So with that in mind, what I want to go ahead and do is I want to write it in standard form. Okay. So standard form, if you remember, ax plus by equals c. Ax plus by equals c. So if the a, b, and c's confuse you, this is the easy way to remember it. X and y are on one side, everything else is on the other. Okay? X and y are on one side, everything else is on the other. So here, what do I need to do so that it fits that? Yep, let's add 3x because let's move the 3x over to the left side of the equation. Because then what's going to happen is the x and the y will both be together, which is what we talked about. And then everything else will be on the right side. So on the left side I get 3x plus y equals what? 4. Now the final check we need to make, okay, a can't be negative. So is a positive here? Yeah, because a is actually the 3. That's the number in front of the x. The other thing we need to check is if I can divide these numbers all by something. So I have the numbers 3, 1, and 4. Can I divide those all by some number? No. Okay. So that is going to be your final answer. Now you're probably wondering, what does she mean divide it? Well, let's say, for example, I have this. 6x plus 2y equals 4. What do you know about all three of those numbers? They can all be divided by 2. That's what I meant when I said, can they all be divided by a number? Okay? All right, so with that in mind, is that following a linear equation, yes or no? So go through the checklist again. Is that a linear equation, yes or no? The answer is no. Why not? You're right. Why not?
It's 2 variables.
2 variables multiplied by themselves, x, y. Remember, we can't have this. All right, is that a linear equation? Yes or no? Now we'll see if you get this one right. It's yes. Okay, so let's go through the checklist again. Has an x, y, or both an x and a y. This has a y, so this is good. It fits that one. Okay, next one. The variables all have powers of 1. Yeah, it has a power of 1, so we're good to go. On the next one, are there any variables in the denominator? Nope. I mean, it has a denominator, but there's not a variable there. And then the last one, do you have variables that are multiplied by themselves, like an x, y? The answer is no. So this is a linear equation. Okay, so let's write this in standard form. So standard form, ax plus by equals c. So basically it means variables on one side, numbers on the other. So we're really, really close. What is the issue with this problem though? What do I need to get rid of? The 1/3. I got to get rid of the fraction because if you remember it said a, b, and c are all integers. 1/3 is not an integer, it's a fraction. So what I'm going to do is look at the denominator. The denominator is 3, right? So I'm going to just multiply everything through by a 3. What is 3 times 1/3? Yeah, so it'd be 1y, right? It's like the 3 and the 1/3 cancels. What do you have on the right? -3. So there you go. Now the question is, what do you do since there's no x? You just leave it out. Okay, because if you remember, it said that a could be 0, which meant that you could have no x. Alrighty. Is that a linear equation, yes or no? Okay, hopefully we're getting a little bit better at identifying these. Okay, should be a little easier to identify. So is that a linear equation? The answer is yes or no. Ooh. You know what? That is not a linear equation. That's actually coded wrong. Okay, why is it not a linear equation? Yeah, go ahead. Because that's got a power 2. It's squared. Can't have that, remember? So that is not a linear equation. So now we're going to talk about intercepts. And this is the final thing we're going to talk about today. This is going to take us probably through a few slides. First of all, x-intercept is where the graph crosses the x-axis. The x-intercept is a point. Okay. So it could be 1, 0. It could be -5, 0, etc. So that is the x-intercept. It's where the graph crosses the x-axis. The y-coordinate is always 0. The y-intercept is where the graph crosses the y-axis. The x-intercept in this case is 0. So you could have 0, 3, something to that effect, 0, -4. Okay. Now I don't know if you necessarily need to write down the graph here. That just kind of shows you the y-intercept of 2. The coordinates 0, 2. X-intercept of -4, coordinates -4, 0. So now we're going to talk about intercepts a little bit. Alrighty, so let's go and see what we have on the next slide. It says find the x and y intercepts of the line graphed at the right. So you're looking for where it intersects the x-axis, that's the x-intercept, and where it intersects the y-axis, and that's the y-intercept. So with that in mind, I want you to look at that graph, and then I want you to answer A, B, C, or D. Okay. So let's see what you got. Okay, the answer is B. Okay, now why is the answer B? Because the x-intercept is 20. That's where it intersects the x-axis. Okay, we're looking at this point right here. The y-intercept is 30, right here. So this is just looking at the graph and identifying what the points are. All right, 0 has no points. So let's go ahead and look at, find the x and y intercepts of the line graphed at the right. Okay, so you're looking for where it intersects the x and the y axis. It did? Okay, and what's it? All right, so the answer is D here. Okay, so let's go and look. Where does it intersect the x-axis? Nowhere. Okay, doesn't touch the x-axis. So in this case, you know there's no x-intercept. So really, you could have stopped right there, and you could have answered D. Or what you could have done is look for the y-intercept and see that the y-intercept here is 150. Okay, and you would have seen that that matched up. Okay, so let's look at this. It says a swimming pool is being drained at a rate of 720 gallons per hour. The table shows the function relating the volume of water in a pool and the time in hours that the pool has been draining. Find the x and y intercepts of the graph of the function. So let's think about that. When you wrote down x-intercept, remember we had the coordinate of a point, right? And so if you remember the x-intercept, what it was is it said some number and 0, right? So this was basically my x and this was my y. So I knew that y was 0 for the x-intercept. So if I look at this chart, where is y 0? What value of x occurs when y is 0? 14, right here. So your x-intercept is at the point 14, 0. Now if you remember your y-intercept was at the coordinate 0, some number. So in this case, I'm looking where x is 0. So in the graph, where is x 0? Right. So I know that my y-intercept in this graph will be 0, 10,080. Now be really careful that you don't put that second comma in there. So it should be 0 and then 10,080. So that's all you're doing. You're just identifying intercepts from a table. Questions on that? Okay, so let's talk about this one. I believe this is our last one. There's the draining in the pool. So this is still the draining in the pool problem. So what do you think the intercepts mean in this situation? So here's my y-intercept. What does that mean?
The pool started out with that many gallons.
So say that louder, you're right.
That's how many gallons the pool held.
Yeah, that's how many gallons of water the pool held. Okay, because it said time is 0, so that's basically how many gallons of water you started with. Okay, so the y-intercept, how many gallons of water the pool held. So now let's look at the x-intercept. That's right here. So what do you think the x-intercept means? How many hours it took to drain it? So in this case, it took how many hours to drain the pool? Right. So it took 14 hours to completely drain the pool. Now, when you think about draining your bathtub at home and it takes like maybe 5-10 minutes, and you're thinking 14 hours, I mean, can you imagine? Water's just running out of the pool for 14 straight hours. It's a long time. All right, so questions? Now, where we're going, tomorrow we're actually going to graph. Okay, so we're going to have an XY plane and we're going to graph lines and do all that good stuff. But this is your assignment. Now, note, this is your assignment for both days. Okay, so technically this assignment is not due until Friday because tomorrow we're going to finish the second half of this lesson. If I were you, though, I would start your lesson tonight. Try and do everything but the graphing so that tomorrow night you're not bombarded and you have a ton of problems to do.